All right, so audio is good. It is streaming. So it's good to check with me at the beginning of a class, just to make sure that I am recording, um, because sometimes I forget. All right. So the first thing we'll do today is to go over the homework assignment, because I want to let you guys know what the solution should be, how it should look like. And also to emphasize that please do not change whatever you have shared with me. Yes.
There's still a little power off standby mode thing.
Oh, right. Yeah. So let's get rid of that. Power off. And instead of a yes and a no, it gives me okay or cancel. I'm guessing cancel is going to get rid of the screen without turning off the projector. Okay. All right, so back to this class. Your previous homework assignment is right here. And I am going to do the homework assignment. Oh, where did it open? Assignment 1. And yes. The AC is on. It's just not set to a very. It's set to 74 degrees. I'm gonna turn it to 72. There we go. All right, so I'm just gonna go to the link and make a copy of that. Okay, so make a copy. And I'll put it into a place where you cannot, that is not shared. Okay, so we'll put it here. Unfortunately, we cannot see it because the screen is doesn't have enough resolution. So let me see if I can do it in a different way. I can put it into shared, just solution. Okay, so I'll put it as assignment 1 solution. There we go. Because no one is supposed to work on it anymore. And if I look at the property of a spreadsheet and the last update is past the due date, I'm not going to grade those submissions. So I think it's okay. We can just go ahead and put it this way. I'm going to minimize that. All right, so this is the code, and we'll take a look at the trace. So one way to replicate it into another window is just to copy the entire link, and then you add a new window, and then put that link into the URL of that window. And this way we can have two browsers on the same page, where one focuses on the code and the other one to focus on the trace. So with this one, you can have a comments, column. It is not needed. So don't worry if yours does not have a comments, column, because there are no conditions to evaluate. Okay, so it's okay not to have that column. You do need a line number column, and also one column per variable. We have two variables in this case. X is a variable, Y is also a variable. And then what you need to do is to look at line one, look at the precondition, and then we ask the question, do we need anything specific in X or Y? And the answer is no. So they are both unknown to begin with. A question mark indicates that something is unknown. Then we can start on line 1. Line 1 is an assignment operator. In fact, all 5 lines are assignment operations. So you evaluate the right-hand side first. It's a constant of 0 in this case. And then you update the left-hand side. So X is updated to a 0 at this point. On line 2, Y is updated to the value of X, which is also 0. On line 3, we evaluate the right-hand side. X currently has a value of 0. 0 plus 2 is 2. So 2 becomes the value of the right-hand side of line 3 at this point. And then we use that to update the left-hand side, which turns out to be X as well. So now X now has a new value of 2. We go to line 4. Y gets twice of what Y used to have. Y had 0. 0 plus 0 is 0. And then we use that to update Y. So y is, even though it is updated, it still has a value of 0. On line 5, x gets y plus 1. Y has a value of 0 at this point. 0 plus 1 is 1. So x is now updated to a value of 1. There are no other lines in this particular pseudocode, so we say post to clearly indicate this is the end of the trace. Do we have any questions about this trace? Yes?
So 4 is still 0, so I didn't put any number in there because it was like still the same. Is that okay?
For this assignment, I'll let it slip. But in the future, if there's any type of update, even if the quote unquote new value is the same as the old value, you still have to kind of indicate that, it got changed, quote unquote changed. But in this particular homework assignment, it's okay because I wasn't clear about that. So thank you for asking. Any other questions about this particular homework assignment? No questions? All right. So if there are no questions about this, we're going to continue to move ahead in terms of our class notes. Okay. And I'm hoping you guys got a chance to read the material before class. At least catch up with me, in the previous lecture. We are now done with loops. Okay. The previous lecture last Thursday was about loops. So what we'll do today is to continue on to nested control structure, which is the next module. I just go through the modules linearly in this class. And so, if you know that we have just finished, loops, the next topic is going to be nested control structure. So that's kind of the implicit reading assignment that I want you guys to do prior to a class. Now, does it mean that I'm going to give you a short quiz and have points associated to see whether you actually read ahead of me or not? No, I'm not going to do that because, reading ahead is only going to be for your benefit. It is not for my benefit. Okay? All right, so we are starting with this one, nested control structure. And it has the older format. I'm going to change it at some point, but it's still usable. It's just that, it appears to be like an older formatting style. So the first question is, why do we have to talk about nested control structure? What do you think? Well, first of all, what do you think I mean when I say nested? Do you see constructs that are quote unquote nested on a daily basis? Okay, some people nod. Okay, a whole bunch of people do not know what I'm asking, or do not show that they know the answer. So yes, the answer is yes. We deal with nested structure every single day. How many people use a computer every day, not counting your phone? Okay, and how often do you have to navigate to a folder, and then there's a subfolder, and then there's another subfolder, and then finally you get to your file? Often, right? Most of the time it's organized that way. So that's what I call nested. Okay, nesting simply means that a construct, like a folder, can be a part of another folder. That's it. Okay, a construct can be a part of another construct. Are we doing okay so far with the term nested? Okay, so nesting is kind of a very important mechanism of structured programming. Okay, so there's programming and then there's structured programming. What is the difference? The difference is in structured programming, we use the concept of nesting to make things easier to understand and also easier to display and also easier to express. Okay? So before we move on and talk about control structures that are actually nested, I'm going to use an example that doesn't seem to have anything to do with coding. Okay, so I'm going to use maps.google.com, and we'll be looking at a map that is, okay, where are we? Up a little bit. And over a little bit like that. And we'll zoom out a little bit. Okay, so we'll zoom out. You can definitely see American River College here. Yes, it's kind of right at the center. But do you see the name of the streets around American River College? Do you see the name of the buildings in American River College? The answer is no, right? And why not? Sorry, go ahead. You have to zoom into the details, but why is it not included in this view? Too much information, and go ahead. Okay. Well, okay, so the too much information part, does it have to do with the limited resolution of this projector? Or does it have to do with, how difficult it will be for you to find something if we are to include, every street number, the name of every single building at this level of the map? It's that, right? It's basically we cannot track all that stuff, okay? Many of you probably do not know have not used an actual physical paper map to try to find, how to get to a certain place because, you guys all, grew up with, smartphones and GPS and devices, right? So what do people do, before you have, cell phones and GPS devices and whatnot? They got paper maps, okay? They got paper maps. So let's just say that I have to go to a particular place in Sacramento, okay? And I don't have a GPS, I don't have my smartphone, there's no electronic device to help me. I go to AAA or some other place, to buy a map, right? I unfold the map, and guess what? It's difficult to find anything because that map contains all the details, okay? It would at least contain block numbers for each block, street number for each street, and if there are buildings with names, those names would be on the map too. So you can kind of imagine you have a piece of paper that's about this big, and it has got tons of names and whatnot on it. It makes it very difficult to find something. So the idea is it is not nested. We're trying to display all information at one single level. The other way to look at for you guys to kind of imagine, why nesting is useful is to think about a file system on your computer that has no concept of folders. You have C:, that designates your hard drive or SSD on the main drive on your computer, and that's it. You cannot have folders. You cannot create folders. There are no existing folders. Every single file is at the level of C:. Would that be a computer that you want to use? And why not?
Because it's too unorganized.
Because it is.
Files will be combined together. Not the files, but the program inside the files will be all combined together. It will be too unorganized.
You will have a hard time to name new files, right? How do you make sure that your new file name does not collide with the name of an existing file? So let's say you're doing your homework, right? This is homework assignment 1 or assignment 1. And let's just say that it is a Word document, docx or whatever, right? Well, which class assignment is it? If you just call the file assignment 1, it's not going to help you, differentiate between, oh, this is, English writing assignment 1 versus, this is whatever, other homework assignment is. So that's why we need to organize and structure, okay? Because we can only keep track of so much information, in our mind at any particular time. Does anyone know the number, like how many things we can maintain in short-term memory? No, I don't know either, but mine is usually pretty small. I cannot track things. Yes, question? No, okay. So let's look it up, okay? I'm just curious. So we'll just look up short-term memory capacity. Okay. So these are tested. Let's see if they have results. The magic number is 7 plus or minus 2. Okay, so I'm getting to this part here. The magic number is 7 plus or minus 2 provides evidence for the capacity of short-term memory. So in other words, most people can maintain, and track 5 to 9 things at the same time. And that's not a whole lot, right? When you look at a map, and if I ask you to locate a particular street on a paper map, that's going to take you a while. Is that making any sense? Now, in programming, it is the same thing. Okay, programs can be very complex constructs, and if we do not structure things and we just say, okay, we'll just display everything all at the same time, it becomes kind of difficult to track. So, the mechanism that allows us to write programs in a structured way is nesting. Okay, so what we'll do today is really just kind of look into the mechanism itself and make sure that we can understand nested statements. So here's an example, which is already including a nested construct. You look at this program, line 1 is pretty easy. Line 1 is an assignment operation. So by this time, we should be able to look at it and understand that, oh, okay, we just want x to start with a value of 0 on line 1. Line 2, 3, and 4, we have seen that from last Thursday. It is a pre-checking loop. While do means, this condition between the while and the do is a condition to evaluate. If that condition is true, we get out. Excuse me, I take it back. If that condition is true, we perform whatever action is specified between the while and the end while. And if the condition is false, we get out of the loop and continue with whatever is after the loop. Okay? In the case that the condition is true, we perform whatever operation is between while and end while. But after we perform that operation, where do we go? After we perform line 3, in this case, where do we go? We go back to line 2 to re-evaluate the condition to see whether we can get out of the loop or not. Okay? So I'm expecting you guys to have studied the material from last Thursday. So I am expecting you to actually know how to interpret all this code today. All right? So just keep that in mind, okay? Because all the new concepts stack on top of older concepts. So that means if we don't clear and practice and be able to understand these concepts, it will make new concepts very hard to understand. Okay. All right, but this is already nested, because line 3. What is line 3 by itself? If you don't think about line 3 being a part of a loop, what is the nature of line 3? How do we call that? It's an assignment statement. Okay, it's an assignment statement. It is a statement, but it is nested in a while loop. So even for something as simple as this, it is already using the concept of nesting, because we call a loop, which is starting on line 2, ending on line 4, to be nesting line 3, which is an assignment statement. So we already have a statement which is serving as a part of another statement in a simple pseudocode like this. Is that okay? Now, but the behavior of this code is not very complex. We talked about this. We actually did a trace on last Thursday of something similar to this. Okay, in fact, we did quite a few traces on loops on last Thursday. So this one is not too complex in terms of what it is going to do, and that's not really a whole lot of confusion either. But when we look at something that is more complex, then we have a bigger question of what is it going to do? So let's take a look at this code here. It is containing a loop inside another loop. So the inner loop, we call it an inner loop because it is contained within another loop. It goes from line 5 to line 8. That is a loop. But that loop is only one of the components of what we call the outer loop. The outer loop goes from line 3 all the way to line 10. Okay? So we have an inner loop, we have an outer loop. So now there are a few questions like, well, what happens when the condition of line 5 is false? Where do we go? What happens when the condition of line 3 is false? Where do we go? What happens when we are done with line 7? Where do we go? What happens when we're done with line 9? Where do we go? So those are all legitimate questions, because this is cisp300, I'm assuming you have no exposure to programming prior to this class. So that's okay, and that's the purpose of today's lecture, is to look into, what do we do when we have a nested program like this, and how do we know where to go when we have several places that we can quote unquote go. So do we have any questions about this code here? No questions? Do you guys notice the use of indentation? In other words, certain lines seems to be a little bit, indented on to the right-hand side. And what do you think? Why do you think there's indentation? Do you think I just accidentally pressed the space bar too many times? Yep.
It's nested inside the other loop.
Yes. So indentation indicates the level of nesting. So, the lines that have the most indentation are the ones that are nested they're the innermost, constructs. So this makes it easier to see visually that line 6 and 7 are nested as components of line 5 to line 8. But we also can tell that line 5 to line 8 is at the same level as line 4 as well as line 9. Everything from line 4 to line 9 are components of the outermost loop, which is from line 3 to line 10. So from the indentation, we can tell which line is a component of which other line, or which construct is a component of which other construct. Yes?
So when you're actually coding and it's not indented, how would you tell?
That is a very good question. So when you're coding and you do not use indentation, how can you tell? Well, let's think about it, okay? So let me just rewrite this code without the indentation. And I'm just going to do it using a notepad or mouse pad right here. Okay. So I'm just going to use less than dash to approximate left arrow. Okay. So I'm not using any indentation, I'm just copying the code. Okay, so I have just copied all the code without any indentation, like that. So now the question is, without indentation, what are we going to do? Well, fortunately, every while ends with an and while, okay? And it is just like parentheses. If you know how to read an expression using nested parentheses, and you know how to track, oh, this parenthesis is the outermost, it is not ended yet, but this one, the inner one, has just closed, and if you can understand that and understand how to group items and operations in an expression, you know how to do this. Because when you get to line 5, you say, okay, this is a while loop inside another while loop. How do we know? Because the outer while loop has not seen its end yet. Okay? So when we get to line 5, we can say, okay, since line 3, the while on line 3 does not have a matching end while at this point, the while starting on line 5 is nested inside the while loop that starts on line 3. It's the same way that you interpret an expression with parentheses. When you get to line 8, you see and while. So and while is just like a closed parenthesis in an expression. It tells you that, well, I'm here to end a particular group. So the next question is, okay, where is the open parenthesis corresponding to this closed parenthesis? You use the same logic to find that, okay, let's go back in this code and find the closest unclosed while. So at this point, if you're on line 8, the closest unclosed while, if you go backwards, is going to be the while on line 5. So now you know line 5 and line 8, one is the beginning, one is the end of the same construct. Is that okay? So you read line 9, which is a part of the outermost loop because that has not ended yet, And then on line 10, this is a closed parenthesis again. So once again, you go backwards and to try to find the closest unclosed open parenthesis. Well, if you go back, the first one you will see is line 5, which is a while, but you know that one has ended already. So you have to go further and go to line 3 and go like, oh, this while has not closed yet. So the end while on line 10 is closing the while on line 3. Yes, go ahead.
So how would you execute this program? Would it be the nested first and then the
That's a very good question. Now, to answer that question, I have two ways to answer the question. The easy way to answer the question is just to click on the next slide. Okay, there's this one here, and I think it will go through a few traces. But the better way to do it is just to do it by hand. So what we'll do is we're going to trace this by hand so that we can explain the whole process. Is that okay? All right. And I'm just going to be lazy and reuse this. So this is going to be nesting code, and then we have nesting trace. Okay, there we go. And this is what I'll do is I'm just going to copy and paste it into where is that? Into the should be, yep, there we go. Alright, so I can just paste it here, but it doesn't have any line numbers. That's fine. I can insert another column, and then we start to have line numbers. And I'm intentionally doing this without any indentation, to basically make 2 points. One is, yes, you can still trace it without indentation. And the second point is, but it's difficult. It's just ugly. Okay. So this is the code, and here's the trace. We definitely need one column labeled comments in this case, because when we evaluate conditions in a control structure, we need comments to tell us, okay, where are we going and why are we going there. We got line number, and we also need one for each variable. So how many variables do we have this time? We have 3, we have x, we have y, and then we have s for sum. So the precondition is we don't need to make any assumptions. So all 3 can be unknown to begin with. Line 1 initializes x to 0. Line 2 initializes s to 0. And y remains unknown at this point. Then we get to line 3. So at this point, I don't think we have any confusion. There's no room for confusion at this point, because line 3, this is the first time we get to line 3 from line 2. So we are still using the concept of sequential statements, because without any control structure, we just go to the next line. Line 1 goes to line 2, line 2 goes to line 3. Okay, so now we are at line 3. Should not have any confusion at this point. So line 3 has to evaluate the condition, which is x is less than 3, and then we have to say whether it's true or not. What do you think?
true?
It is true, because x has a value of 0, so the condition is true. So anytime you have anytime the condition of a while loop is true, you perform the body of that while loop. So where do we go next? We go to line 4. Okay. I'm hoping nobody thought about going to line 6, because the syntax quite clearly indicates that line 4 is the beginning of the body of the statements corresponding to line 3 instead of the one on line 6. Is that okay? Yep.
Why'd you put y equals 0? Why'd you put that statement inside while loop? Because that's just going to keep stating that y equals 0.
Well, we'll find out. Okay, so we'll find out the behavior of this code. This code doesn't serve any particular purpose other than demonstrating, how we track down, nested control structures.
But, well, is there a reason that it's inside that? Or
Is there any reason what is inside?
that it's inside a while loop instead of outside a while loop?
What is inside the while loop?
Because you stated x equals 0
It is in the loop. You mean why this is inside this loop? Yes, that is intentional because then we can see how for each outer loop we reset the value of y back to 0. So it contrasts the line 1 and line 2, which are outside of the loop. Yes, go ahead.
That help us solve the loop sequentially.
Say that one more time.
That help us solve the loop sequentially.
Well, when you have a control structure, you can only go linearly for so long, and then it becomes non-linear because at one point you have to go back to the beginning, and at another point you have to get out of the loop. So it doesn't stay linear for too long. Yes.
So if you don't stay linear, you don't go in order. Like, how do you know which one to go back to?
Well, that's what we'll be talking about. Yep. All right. So. Is that okay? That we are going to line 4 after line 3? Okay. And I'm just going to shrink the size of the columns a little bit. Okay, do you guys have any questions back there? Say that one more time. Okay. So instead of asking him, ask me instead. Okay. All right. So we are on line 4. What does line 4 do? Line 4 doesn't do much. All it does is to initialize y to 0. So y is now 0. From line 4 to line 5, I think just using the concept of sequential operation is enough. Okay, because line 4 is just an assignment statement. It doesn't change the flow of a program. So we just naturally move on to the line following it. So now we get to line 5. Is that okay? No? Why would I want to loop back?
Because still is x less than 3.
But where is the end of the while beginning on line 3?
Line 10.
Are we there yet? So we have no reason to go back to line 3. Because the loop starting on line 5, ending on line 8, is quote unquote the second item inside the body of the main loop, the outer loop. Okay. All right. So I think I can stop right here. I can pause the trace right here because I think the question is how do we draw a picture representing that logic? I think that's probably a better question to answer first before we go further into tracing it. Is that okay? Okay. So we'll go ahead and do it that way. And to do it that way, I'm going to use my tablet, just because this way I can actually do some drawing. And let's see, I'm gonna open a new page. Okay, there we go. All right, so I want to show both the code and the picture at the same time. So this is how I'm gonna do it. And I have to move things around a little bit too. Use a thinner pen. All right. So before we go any further, let's take a look at the shape of a while loop, okay? Because that's something we should know at this point. So if I say, okay, while C, do, and then we have statement 1 and while, okay? So in this case, C is really just a placeholder of a condition, and then S1 is really just a placeholder for one or more statements, okay? I don't know exactly what I want to do. I don't even know what the condition is because I just want to focus on the structure of a while loop. Is that okay? So I'm not, giving you a concrete example. I'm showing you the generic while loop. So the way I draw this, is, we come in from the top, and I have to indicate the directions very carefully. This is where I can come back, from the body of the loop, and then this is where I can branch out. Okay, this is where I can decide which way to go, and this is the question, okay? I evaluate the condition C here. If the condition C evaluates to true, this is the path that I will follow. If the answer is false, this is the path that I will follow. So right here we have a branch And depending on the answer to that condition, I can choose one or the other branch. If the condition is true, I get to here. And what I need to do when the condition is true is specified by S1. I don't know exactly what it is, but I don't need to because I am more interested in the structure of a loop. After S1, which can be one single statement, which can be a whole bunch of statements, it doesn't really matter. When that is done, I go back to reevaluate the condition C. On the other hand, if condition C is false, then I can get out of the loop like that. Is that okay? I mean, is this okay? All right, so this is the picture that we looked at last week, and it applies to every single while loop. Okay? Are we good? Okay. Yep.
This one has nested loops, so how do you show that?
Well, so let's check out what happens when we have a nested loop. Okay. So let's go ahead and start another page, but this time we are looking at the specific code that we want to track down. Okay. So the first thing we want to do is x gets 0. Okay, x gets 0. But x gets 0 is not even a part of a loop, so it really is just something that we need to do, followed by s gets 0, which is also just something that we need to do. So right here, it is all linear. In other words, it's just a sequence. We do one first, and then we do the second one after the first one. And then we get to a while loop. Now, how do I know we get to a while loop? Because of the keyword while on line 3. So this is where I can insert the template of a loop. Okay? So every time we have a loop, we know that the template goes like this. Okay? We have a way to merge from later on, and then we have a split so that we can say, well, is it time to get out? If it is, let's get out. Right? And in this case, I'm going to leave a lot of space to specify what I can do or what I want to do inside the body of this loop here. Okay, so I can make this kind of long and big and have a lot of space for it. And then this part here that skips over, okay, I can just zoom out a little bit and then zoom back in when it's time to zoom back in. So what do I do here? How should I continue from this point? Where should I go? Go back to the beginning of the loop. Yes. Okay, very good. So even though I'm not even done knowing what I need to do from the inside the body of the loop, I know this. I know that when I'm done with all that stuff, we have to go back to the beginning. Is that okay? And when the condition is false, I also know that we just kind of move on. Well, there's nothing after this code, so we just get to post. Okay. So is that picture okay at this point? I know it's zoomed out quite a bit, but the idea is the shape of a while loop stays exactly the same whether there's stuff inside or not. Or it's regardless of how much stuff is inside the body of the loop. Yes?
So what if there's a loop within a loop? The picture would still stay like that? You wouldn't add on to it?
I would draw another loop inside here. But let's not worry about that, okay? So let's only look at the loop that is from line 3 to line 10. Let's ignore what is from line 4 to line 9, okay? Because line 4 to line 9 is only specifying what is inside this chunk here that I have reserved to specify what to do for each iteration of the outer loop. Is that okay? So this is, look at the outer loop as a folder. Okay, it's just a folder. It says, I can contain subfolders, I can contain files. I'm just a folder. Is that okay? So let's make sure that we know what the outer loop, is supposed to do in terms of the condition. So I'm going to zoom back in a little bit because I need to specify how do we decide whether to get out or not. So here is where we can ask the question. X is less than 3. Is it the case? Is it true or false?
It's true.
If it is true, we go here, and if it is false, we go here. Are we still okay?
Yeah.
All right, good. So line 4, okay, if I were to say line 4 to line 9, specifies what goes into this container that is currently left blank. Are we still doing okay so far with this? So whatever is after the word while and before the words and while of the same at the same level is specifying what to do for each iteration. Are we doing okay so far? So what do we do now? Okay, what we do now is to say we have already taken care of the outer loop at this point. So that is no longer my concern. Well, if that is no longer my concern, I'm going to zoom in. Oops. Oh, that's not. It's too much. Well, I guess it's okay. So we're going to zoom in, and we can now ignore the fact that we are dealing with something that is inside the loop. Now we focus on line 4 to line 9. Is that okay? In other words, we just pretend that line 4 is the beginning of some pseudocode. We look at line 9 as the end of some pseudocode. We totally forget that they are a part of a loop. Is that okay? It is analogous to when you double click on a folder, Windows will display just the content inside the folder. And at that point, you don't have to remember that, oh, this is under cisp300, which is under documents, which is under C:\\, which is under your home folder, which is then under the C:\\. But when you open up a folder, you just focus on what is in the folder. You don't need to know how you got there in the first place. Is that okay? So now we focus on line 4. Okay, line 4 says x gets y gets 0. There we go. So over here we say y gets 0, and if you like to give it a little, if you want to represent it just like the outer portion, that's fine. And now we have a loop again. We get to line 5. What do? We draw the template of a loop first. Okay, what does that look like? Okay, I know in this class that looks kind of tedious because of the way I want to represent it, but you have a way to come back from the body of a loop, and then we can split. And there's always a question to ask when you say, is it true or is it false? And in this case, the question to ask is y is less than 2. Is it true or false? Are we doing okay so far with this? This is the beginning of the loop. In text, it is starting on line 5. Okay? What do we do inside this loop? Well, I don't want to be too concerned about that at this point. I just say, yeah, there's a chunk of stuff we need to do. Okay? What do we do after we have performed the body of this loop? We get back to the beginning. Right? This is the same shape, the same structure of every single while loop. When the condition is false, then I proceed to whatever is after the loop. Is that okay? So inside the block here, okay, inside this block is what we specify on line 6 and line 7. So if you look at line 6 and line 7, those two lines specify what we need to do in here. Line 6 says y gets y plus 1, and line 7 says s is s plus x plus y. Okay? Is that okay? So is there anything that I need to do after, right at the exit point of the inner while loop, right here? Do I need to do anything at that point? Which line would that correspond to? Line 9, right? So line 9 is what I need to do because line 9 is after the inner loop. So we have to remember that we still got something to do after that. So let's right here, see, line 9 is even on the original picture. So now we say x gets x plus 1, and that's it. Okay, that's the last thing we need to do. Is that okay? Does everybody understand how I constructed the picture? Okay. So yes, it is. It looks kind of nasty, because when we use a pictorial representation, it's always going to be a little bit more messy than the text version. But if we want to look at the pseudocode on the left-hand side in a pictorial way, this is what it would look like. Yes.
So if we think it as a real code and we render it in the browser, which loop going to render first? Inside loop or outside?
Well, you follow the directions now, right? So we start all the way here, right? We get to x gets 0, we get to s gets 0, right? So now we get into the outer loop. We just follow the arrows. We get to this point where there's a split, but every time you have a split or a fork, you have to ask the question, which way am I supposed to go? Well, there's only one way to find out. Look for the condition associated with that split. In this case, it is x is less than 3. So if x is less than 3 is true, we follow it into this compartment here. If x is less than 3 is false, then we get all the way around and there's nothing else to do in this particular case. Is that okay? So what do we do if x is actually less than 3? Then we get to here, then we get to the inside here. The first thing we need to do in this case is y gets a value of 0.
We are not done with the outside.
If we are here, then yes, we are not done with the outside loop. Is that okay? Okay. All right. So given this is how we interpret the text version of the code, let's see if we can continue with our trace.
I have a question.
Yes.
On line 2, it says s gets 0. That's a condition. And
It is not a condition.
it's a statement.
It's an assignment statement.
And there is no need for evaluation of that one. And this.
Of course, we have to evaluate that. So when we trace it, we have already gone past that point. See how line 2 is already, we have already executed line 2, and it results in the sum variable s having a value of 0 instead of unknown. Okay? So should we continue with the trace, or do we have any further questions about the pictorial representation of a nested control structure? Trace? Okay. All right, so this is the nice thing about the trace is, you can pause at any point and you can resume quite easily as well. So we'll just say that, okay, we are done with line 4. Where do we go next? We go to line 5, okay? So line 5 is the beginning of a while loop. It has a condition to evaluate, which is y is less than 2. Is it true or false?
True.
It is true. Then where do we go?
6.
We go to line 6, and line 6 says y gets y plus 1. Y is column D, and it goes from 0 to 1 in this case. And then where do we go? Well, this one is easy because it's all sequential. So from line 6, we don't really have a choice. We don't have an option. We go to line 7. Line 7 says, let's add up all 3 variables, and the sum would update to s. 0 plus 1 plus 0 is 1. So sum or s variable s gets 0 at this point. Now we have to ask the trickier question of where am I supposed to go at this point? We go back to line 5. Exactly. Now how do we know we need to go back to line 5? There are... Sorry?
The first end while for the second one.
Exactly. So if you look at a while as an open parenthesis and the end while as a closed parenthesis, when we are done with line 7, we have to go look for the beginning of the corresponding while loop, and that turns out to be on line 5, and that's where that's where we need to go back to. Yep.
We will keep doing this until the value is false.
Until the condition of line 5 is false. Yes. Yep. So that's one way to look at it. But at the very beginning of this class, um, I, I think it's okay to refer to the pictorial representation as well. So when you have a homework assignment that has a nested control structure, you can, if you want to, draw a picture first, and then that will give you an idea of how to follow the flow of the program. Okay? Now, if you say, I don't really need a picture because I actually do understand, how to track the program in text, that's fine too. So different people learn differently. Some people are more visual, so those people may find a picture to be helpful. And some people learn, kind of more abstractly, so those people may feel that I don't need a picture to help me. Either way is fine, okay? It is whatever works best for you, okay? So from line 7, we go back to line 5. This is an important transition because we have to know, where to go back to. So is the condition true or false? It is still true because our y has a value of 1 at this point. Then we go back to line 6. Line 6 increments y by 1, so it becomes 2. Now I have to teach you another trick using a spreadsheet. In Google Spreadsheet and most other spreadsheets, there's one way to drag it's a dividing line, okay? So the nice thing about this is now I can scroll two portions differently. So I can have the header of the columns remain at the top of the spreadsheet while scrolling through the rest of the spreadsheet. So that makes it easier for me to track things
Like freezing the upper portion of the
on the spreadsheet.
spreadsheet.
Yep, Excel can do it. LibreOffice can do that too. Question? Huh? Say that one more time. How did I do it? So the way I did it was okay, so let's undo it first. Okay, I'm gonna undo it first and redo it. Okay, this is how things looked like originally. So what you do in Google Spreadsheet is you locate this kind of thicker bar at the very top, okay? And when your cursor is hovering over it, you can see how it changes the color. It doesn't change the shape of the cursor, but it changes the color of that bar. So that means it's draggable at this point. So what you do is you drag it. You can drag it down like all the way here, but it doesn't help me when it's all the way down there. So all I really need is to make sure that row 1 is continuously displayed. So all I need is for that bar to end up here. Is that helping? Okay, excellent. Sorry? You get it? Okay, cool. All right, so we can continue the trace now. On line 7, we add up all 3 variables, and the sum goes to s. X is still 0, y is now 2, and s is 1 itself, so the total is now 3. And then from line 7, we always go back to line 5, okay? So we go back to line 5 and we reevaluate x is less than 2. What is the answer? It is now false because 2 is not less than false. 2 is not less than 2, so y is less than 2 is false. Okay, so here we have another moment where it is kind of important to know where am I supposed to go. The condition of a loop is false. So you got 2 choices really, okay? The first choice is, well, okay, you have 2 things to consider. One thing to consider is we go to post, because post is, after all, after and while. But the second one is to go to line 9. Which one would it be? We go to line 9, okay?
We wouldn't say end while to end that certain loop, or we just like leave it, or we just go to line 9 directly. We wouldn't say like.
I just go to line 9 because end while does not do a single thing, so it cannot be traced. So we get to line 9, and line 9 says x gets x plus 1. So x, okay, I think it's okay for me to decrease the zoom just a little bit. Is that okay? Because otherwise I can't track too many things without scrolling, which is confusing. So this way I can say, okay, x is now incremented by 1. So it is now 1. And then where do we go? I'm done with line 9. Yes? We go back to line 3. Very good. Because line 9 is the last thing to do as far as the outer loop is concerned. So we have to go back to the beginning of the outer loop, not the inner loop. Okay? So we go back to the beginning of the outer loop, which is on line 3, and then we evaluate x is less than 3. And is that true or not? It's still true. Then where do we go? We go to line 4. Line 4 is the beginning of the outer loop, and y is now reinitialized to 0. So here is the answer to an earlier question. Why do I reinitialize? Why do I put the initialization of y inside the outer loop? It's because if I don't do this, okay, if line 4 is actually before the while loop, then it will never get reset to 0. Which also means when I get to line 5, that condition will be false to begin with, because y already has a value of 2. So that means it's not going to do anything interesting anymore. So is that answering your earlier question? Okay. All right. So on line 4, y gets reinitialized to 0. Then we move on to line 5. Y is less than 2 is true because y just got reset to 0, and 0 is less than 2. Then we move on to line 6. Y gets incremented from 0 to 1. And then on line 7, we have to add all 3 variables together. This is getting to the point that I don't trust my arithmetic anymore. So I'm going to do this trick here. This is a spreadsheet. So with every spreadsheet, you can specify formula instead of specifying the values and typing it in. So when you specify a formula, you can start with the equal symbol, and then you just click the cells that you want to refer to, and then just type the operation you want to do to the value of those particular cells. So now I can specify, I just want to add these 3 cells together, so I don't have to do the calculation by hand myself. Is that okay? Now this is not a spreadsheet class, so when you work on the trace and you don't want to do it this way, you just want to kind of do all the calculations by hand and just type the answer in, that's fine. Okay, I'm just telling you that there's a more reliable way to do it if you want to learn how to use a spreadsheet. Is that okay? All right. There we go. So S is now updated to 5. Then we go back to line 5 again. Y is now 1. 1 is less than 2 is true. We go to line 6. Y is now going from 1 to 2. We go to line 7. We add up all 3 variables. So we just say equals. So we have 1 x plus y plus s, which is here. Now it is 8. We go back to line 5 again. And y is less than 2 is now false, right? You can see the rest of this trace is going to be, fairly mechanical and boring. But do we have any questions at this point? I mean, I will finish it, but I do want to make sure that as we go through the trace, that I'm not ignoring any questions that you have during this process. Question? No? Okay. Does anyone have any questions about what we are currently doing? No questions? Okay, so then I'll just kind of follow the code and finish it as quickly as possible. So from line 5, when the condition is false, we get out of the inner loop. So we continue execution on line 9. X is now incremented from 1 to 2. And you can see how this is actually going to be quite boring. Yep, go ahead.
Why would you go to 9?
Why would I go to 9 from line 5? Yeah. Okay. So on line 5, when we evaluate the condition on line 5, it is false because at this point y has a value of 2. 2 is less than 2 is false. Right? Exactly. So when the condition of a while loop is false, then you locate the corresponding end while, and then you continue with whatever is after the end while, which in this case is on line 9. Yep. If you need some time to kind of write down your own understanding of the material on your notes, just let me know. Okay, if you just raise your hand and go like, okay, I need to write down something, pause. I would just kind of stop. Is that okay? Because I can see a few people writing something. I'm not sure whether you can listen to me and write at the same time. So are we good at this point? Okay. So at this point, you can probably just kind of imagine the next iteration is going to look almost exactly the same like this, except x now has a value of 2, but the structure of the code is going to be the same, right? Do you want me to hand trace this, or do you want me to use a very lazy method to finish this? Lazy? Okay. So if you want this to be lazy, I'm going to change this 1 first. Okay. Then you go like, 1 is pretty simple already. How can you simplify this 1? Well, remember, when we get to line 9, we are incrementing the value of x by 1, right? So instead of specifying this as a 1, what I can do is I can say this value here is whatever x had before. Okay, that may not work. Never mind. So I have to keep this 1 here. But this 2 can change. Instead of specifying a 2, I can now say, well, it is whatever x had from the previous update on line 9, whatever that is, plus 1. Then you go like, but Tech, you just typed more than what you had already. Because I just typed a 2, right? Which is like 1 keystroke. Now it has several keystrokes because I have to specify this as C14 plus 1. Oh, by the way, what is C14? What is it referring to? It's referring to the cell at column C, row 14. Okay? So when you look at a formula in a spreadsheet, it tells you, when you see C14, it's telling you we are referring to column C, row 14, which is this particular cell. Is that okay? But that is actually a good thing to do, because from here on, I can just copy and paste. So I will take this all the way from here to here. Control C to copy this entire block. Control V to paste. Now we have the next iteration done with a single keystroke. Now you guys will go like, I don't believe that, okay? Well, and you should not, okay? You should not believe me. Even though I am the professor, in this class, sometimes I make mistakes. Sometimes I do something just to see if you understand the concept or not. So you do not take things for granted here. You always want to say, wait, hold on a second here. I need to make sure that that is actually true. So what do? You basically just go through all the trace lines manually to make sure that it is all okay. So from line 9 we get back to line 3. That kind of makes sense because line 9 is the end of the body of a loop and line 3 is the beginning corresponding to that loop. So going from line 9 to 3 is correct. X is less than 3 is true, yes, because x has a value of 2. So far so good. On line 4, we update y, so we reset y back to 0. Yep, okay, that's what we did. So far so good. On line 5, we check whether y is less than 2. Y has a value of 0. 0 is less than 2 is true. So far so good. We move on to line 6. Y is incremented by 1 at this point. Then we move on to line 7. Line 7 wants to add up all 3 variables at this time, so we need to double check that. X currently has a value of 2, Y has a value of 1 at this point, and S, the sum, has a value of 8 at this point. When you add up all 3, they do add up to 11. Okay? Then we go back to line 5. Y has a value of 1. 1 is less than 2 is true. We go back to line 6. On line 6, we increment the value of y from 1 to 2 in this case. Then we move on to line 7. On line 7, we want to add up all 3 variables again. Sum itself has a value of 11 plus 2. from variable y that will give me 13, and then plus another 2 from x that will give me 15. So far so good. From line 7, we always have to go back to line 5. We go back to line 5, we evaluate y is less than 2. Y is already 2. 2 is not less than 2, so y is less than 2 is false. Then we have to exit the loop and move on to line 9. And on line 9, x is incremented from 2 to 3. So the copy and paste actually worked. But it would not have worked if I did not use formulae to update the values of cells. The use of formulae allows me to copy and paste a block of code because the value of the new cells is now calculated from the value of other cells. Okay? Does it mean that you have to do your homework assignment the same way that I do? Use all the formulae and then use copy and paste? The answer is no. Okay? If you feel more comfortable doing everything by hand, do it by hand. On the other hand, if you say, yeah, I have taken a class or two in Excel spreadsheet already, this is all pretty easy concept for me because I have taken the class, then you can go ahead and use the technique that I showed. Okay? So whatever you feel more comfortable is the way you do it. Okay? You just have to make sure that you understand the concepts behind the trace. So from line 9, where do we go?
Line 3.
Go back to line 3. Very good. So this time we are re-evaluating the condition of line 3. X is less than 3. Is that true or false?
False.
It is now false. Very good. And then where do we go?
Line 10.
We do not go to line 10.
Post.
We just say post.
Also, N1.
Hmm?
I mean, the last line is the post line. I mean, N1. It has nothing to do with it.
So, okay. Let me answer his question and then I'll get back to this. Yep.
So the loop is closed when the condition is false then? So like the loop is done once the condition becomes false?
Yes. So in the case of a pre-checking loop, which is a while loop, when the condition is false, then you get to the end, you get past the end of that particular loop, and if there is any code after that, you continue execution. Right, but in this case, there's nothing after that, so we get to post basically right away. Yep, good question. And getting back to your point, okay, we do not trace and while because it is ambiguous. Is and while going to be something that you trace per iteration, or is it something that you only trace when you get out of a loop? Well, the answer is we don't know because and while is no more than an indicate. It's close parenthesis, right? Because its only purpose is to say, in terms of syntax, this is how we indicate the end of a while. So it doesn't really do anything other than, yep, I'm just marking where it ends. And that's why we don't trace it. We do not execute that line. Okay? Yep.
Is there a rule for comments or like for us typically?
I would just do it like this. You repeat the condition of whatever construct you are evaluating, and then you indicate the result of that evaluation. So you have to tell me what is the condition, what is the expression, and after you evaluate it, is it true or false? So I would just kind of do it like exactly the way I do it here. Yep.
So in a nested loop, we always have to finish the inner loop before the outer loop?
Yes. Because the inner loop from line 5 to line 8 is really the second component of the outer loop. The first component of the outer loop is line 4. The second component of the outer loop is the while loop, which is from line 5 to line 8. Look at this as a folder. We are just expanding the content of all the folders at this point. We get to see everything. But if you imagine we can collapse the folder, you can basically say, oh, we collapse line 5 to line 8 to one single line. That is kind of one other way to look at it. Yes?
Was line 3, so the inner loop, was it created by the line 3?
The inner loop is not, it is a component of the outer loop. but it is not created by the outer loop. Okay, let's approach this using another way to look at this. Okay, look at line 1 as a folder on your C drive at the very high, the top level, under C:\\. Okay, line 1 and line 2 are both just regular files, in C:\\. Is that okay? So they cannot contain anything because they are just regular files, and files cannot contain other files. Then you have a folder. Okay, at the root level of your drive, you have the third item is a folder. That folder is corresponding to line 3 to line 10. Is that okay? So you double click on that folder, which is the third item at the root level of a drive. And what do you see? You see 3 items. The first item inside that folder is line 4, which is a file. It cannot contain anything. It is just a regular file. The second item is from line 5 to line 8. It is a container. It is a folder by itself. And then the third item is line 9, which is a file, just a regular file by itself. Okay? Well, if the second item is a folder, you might be curious of, okay, what is inside that folder? You double click it. When you double click that item, then you get to see line 6 and line 7 as individual files inside a folder, which is also inside another folder. Is that okay? I mean, is that a way to kind of visualize and understand how to look at statements that can contain other statements? Yep, okay, very good. So it might take you a little bit of time to really get used to these concepts. So that's why I give you homework assignments, okay? So you do have a homework assignment for, it's another week-long homework assignment. You have 1 week to work on it. I suggest that you get started as soon as possible so that if you do have any questions, conceptual questions especially, then we can talk about that on Thursday. Yes?
Homework like similar to this.
The homework is very similar to this. It is not. Let me see if I can find it. Okay, so this is wrong class. Let me go back to the right class first. I'm clicking on the wrong tab. So your homework assignment 2 is called nested trace. Okay, so when you open it, it looks very much alike the other one because the construct, the structure is the same, except the link is different. So this one will bring you to a different startup point, which is labeled assignment 2. You have to do the same thing, make a copy of, get your own copy, put it into your own drive. And you can look at this, it's not the same, okay? It's not exactly the same. It has some resemblance, okay? But if you want to check whether you understand the concepts or not, I would refrain from looking at today's trace and just go like, oh, it's going to be about the same, just kind of follow that stuff. I would just go ahead and look at this program as if it is an entirely different program. Start the trace from the beginning, do everything yourself, even though the control structure has similarity to the one that we did today. So you have code as one tab, as one sheet inside the document, and then you have trace as the one that you need to, that's where you need to put your trace. Is that okay? So once again, it is due in a week, okay? Which gives you Thursday as a potential date to ask question if you start early. Yes?
When will be graded the last assignment?
The one that's due today? Well, I will probably grade it over the weekend or whenever I have time. Yeah, because it's all going to be manually graded. It's not like I click a button and something will automatically grade everything. Yep.
I already have a question about his homework.
Uh-huh.
X minus 1 on line 9. Is it just going to keep looping?
No. Well, that's my answer, okay? But I'm not going to tell you why. You kind of have to do it to realize why this is not an infinite loop. All right, so I'm going to end today's lecture. The video will be available, within a few minutes, and I will see you guys on Thursday. But try to get started on this one early, so that way, if you do have questions, we can address those.